Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to use the reactions between metals and water and metals and acids to construct a reactivity series. You should then be able to describe in terms of electrons what happens when metals react. In the next video, we're going to look at how we can use the reactivity series to explain the displacement of metals. In a previous video, we looked at how group 1 metals react with water, and I'm showing you here the reaction of potassium with water. As you can see, this is an extremely vigorous reaction. When potassium reacts with water, we make the alkali potassium hydroxide and the gas hydrogen. Here's sodium reacting with water. As you can see, sodium reacts less rapidly with water than potassium. When sodium reacts with water, it produces the alkali sodium hydroxide and hydrogen gas. Finally, here's lithium reacting with water. Lithium reacts more slowly than either potassium or sodium. When lithium reacts with water, it produces the alkali lithium hydroxide and hydrogen gas. So I'm showing you here all of the reactions that we've seen so far. As you can see, reacting a metal with water produces a metal hydroxide, which is an alkali, and hydrogen gas. Calcium reacts with water in a very similar way, so I'm showing you that reaction here. We make calcium hydroxide and hydrogen gas. Calcium reacts fairly rapidly with water, but it's not as rapid as potassium, sodium, or lithium. So as you can see, as we move down this list, the metals react less rapidly with water. By testing a whole range of different metals with water, we can work out the reactivity of the metals. I'm showing you the reactivities of the different metals with water here. Potassium, sodium, and lithium react very rapidly with water at room temperature. Calcium reacts quite rapidly with water at room temperature. Magnesium, zinc, iron, and copper have got no reaction with water at room temperature. So we can use the reaction with water to determine the reactivity of potassium, sodium, lithium, and calcium. But we cannot use water with magnesium, zinc, iron, and copper, as they don't react with water. So if we want to compare the reactivity of these last 4 metals, then we need to react them with dilute acids. We're going to look at reactions of metals with acids in later videos. So here are the reactivities of the metals with dilute acids. Firstly, we'd never react potassium, sodium, or lithium with acid, as they'd react too vigorously and that would be dangerous. Calcium reacts extremely vigorously with dilute acid. Magnesium reacts rapidly. Zinc reacts quite rapidly, but is less rapid than magnesium. Finally, iron reacts slowly with dilute acid, and copper does not react with dilute acid. So what we've created here is called the reactivity series for metals, and we're going to be using this a lot in the next video. Now, scientists usually include 2 non-metals in the reactivity series because they're used a lot in chemistry, and these are carbon and hydrogen. I'm showing you these here. I should point out that you're not expected to memorize the reactivity series, but you could be asked to construct one from data on how elements react. Okay, so we've seen that different metals have got different reactivities, but what actually determines how rapidly a metal reacts? Let's look at this now. The first key fact is that when metals react, they lose electrons and they form a positive ion. So this shows potassium forming the potassium ion K+ and losing 1 electron. The reactivity of a metal depends on its ability to lose electrons and form a positive ion. So looking at the reactivity series again, we can see that metals at the top, such as potassium, readily form a positive ion, whereas metals towards the bottom, such as copper, are much less likely to form a positive ion. Remember, you'll find plenty of questions on the reactivity series of metals in my revision workbook, and you can get that by clicking on the link above. Okay, so hopefully now you should be able to use the reactions between metals and water and metals and acids to create a reactivity series. You should then be able to describe in terms of electrons what happens when metals react.